All right, welcome back to the third part of this segment. We are talking about items that we can actually measure when we deal with electricity. We talk about current, we talk about voltage. So now we'll talk about the third item, which is called as resistance. So remember, we talk about a water flowing, a water system. So let's recap. We talk about a water pump at the start. A water pump will give you the voltage from like a battery. Your water that is flowing itself is the current, and the rocks that block it itself is called the resistance. So this is the example that we use. So today we talk about resistance, which is the rock, the thing that prevents this current from actually flowing in electricity. So resistance is something that opposes the flow of current. Opposes means block, that means go against, do not allow. Conductors have lower resistance while insulators have higher resistance. Recall, we talk about conductors. Conductors are example like your copper wire. They have very low resistance. That's why electricity or electric current can flow through. Whereas for light bulb, the light bulb have very, very high resistance. Imagine you have a wire that have a very high resistance. It has a lot of rocks inside. It prevents the current from flowing, prevent the water from flowing into the water pump, prevent this current from flowing through. So they all get stuck there. When this current gets stuck there, they get angry, they get agitated, they get hot, and they start to light up and burn and glow. That's how light actually is being produced. Okay. So understanding resistance, low resistance, water flows quickly because there is nothing to block it. But when there is high resistance, water flows slower because there is something blocking it. It can be a rock, it can be a tree trunk in this case, or it can be anything else that blocks this current or water, in this case, from flowing through. So how do we know whether the wire has a high resistance or low resistance? So usually longer wires, in this case here, have higher resistance. So long means higher resistance. How about the size, the area, the thickness? Okay, so in this case, the smaller, the thinner the wire, okay, or the smaller the cross-sectional area. What is cross-section area? Imagine you look at a wire here. This is your eyes. Okay, you look at the wire here. You realize that the wire has a certain size. Okay, so this is your wire. This area here, this area is called your cross-sectional area. Basically, it's just the area. So if this area here is very, very small, or what we call as thin wires, then the resistance is very high. So you say, so how do we remember this? Very good. So let's give an example. If you are crawling through a tunnel, okay, so you have a tunnel here. So you have a tunnel, and you have a man of this size. Okay, let's make this man smaller. You have a man here walking through. Okay, so if your tunnel has a very big area, that means if your tunnel is big like that, the man can just walk through, very, very low resistance. But if your tunnel is very, very small area, this man will have to crawl through. And if he were to crawl through, there is a lot of resistance because it's very difficult to do so. So the bigger the tunnel, in this case, your tunnel is the wire. The bigger the tunnel, the bigger the wire. In this case, the resistance, do you think will be high or low? Will this person be able to walk in easily? Yes, he's able to walk in easily, so resistance is low. Okay. Similarly, if your tunnel is very long, the person will take forever to go through, very high resistance. Okay. Okay, so how does resistance affect the current? The higher the resistance, the smaller the current in the circuit. The higher the resistance, the smaller the current. Does it make sense? Yeah. So imagine you have a river. There is a lot of stones, so many stones that it block up the river. Do you think your water, which is the current, can flow through? No. So the more stones there are, the higher the resistance. The less water can go through, the lesser the current. Okay. So okay, let's look at an example here. If we have two bulbs here, the resistance is higher. that means there'll be a lower current, the light bulbs will be dimmer. Okay. If we have one light bulb only, then the resistance will be lower. Higher current, the light bulb will be brighter. So your brightness depends on your current flowing through. So I recap again. If you have high resistance, there will be low current because there's a lot of rocks, your water cannot flow through. If you have low resistance in this case is here, you have very, very little rocks, your water can flow through very easily, so high current. So what is the unit we use for resistance? Remember current and voltage. We use different units. For current, we write as ampere. For voltage, we write as volts. But for resistance, we write it as ohm. So how do we write this? This is like an octopus. Okay, ohm. What is the device that we use to measure for your resistance? We use a multimeter. Okay, and this multimeter must be set to resistance mode because a multimeter, from the word multi, can measure multiple things. The multimeter can measure current, can measure voltage, and measure resistance. So to measure resistance, let's just use the resistance button, the resistance mode in this multimeter itself. Okay. All right, so let's run through here. What are the errors in this if you want to bring in the two previous parts? Remember your positive battery. See, this is an ammeter. Okay, the positive must be connected to the positive. So let's circle where are the errors. This is the error. This should be positive. Okay, this should be negative when it's connected. All right, next, let's look at here. What is wrong here? The connection for this is wrong. Why is that? This is your voltmeter. Remember, your voltmeter must not be one after the other. It must be connected in parallel, correct? So how do we connect in parallel? Connect here, up, and then we draw your voltmeter. Okay, so this will not be the diagram for voltmeter. At later lessons, we will learn how to draw the circuit diagram for the voltmeter itself. Let's move on. So a resistor is a component that provides resistance. So we don't use rocks in our wires, okay, to provide resistance. We don't use rocks. So we need to use something else. We use resistor in this case. There are two types. One is a fixed resistor, and another one is a variable resistor. What is the difference? When there is a fixed resistor, your resistance is fixed no matter what happens. It cannot be changed anymore. But you can put in another device that changes your resistance anytime that you want. You just need to turn it, you need to on it or whatsoever. This resistance can be adjusted. So what is one thing in your classroom or at home that you can turn? The fan knob, correct? Your fan, the knob. Okay, your fan, you can change the speed 1, speed 2, speed 3. That is actually a variable resistor. Okay. So what is the use of resistors? It can be used in many devices, such as your radio, such as in your computers, such that you can change your resistors to get the current that you want. You want more current, you change it to lesser resistance. You want lesser current, you change it to more resistance. So for your radio, can you see you can control the volume here? Okay. And your circuit board itself, there are various resistors as you can see here. Okay. So we will end off for this section itself. The next section we will talk about is on series and parallel circuits. All right, thank you very much.